energy. Our first topic is atoms and molecules. The blue dot is for neutron, the red dot is for proton, and the black dot is for electron. And this is how the atom should look like, where the electrons surrounding neutron and proton. What are simple molecules? It's atoms combined together. And here's an example. In real life, oxygen. And this is the formula for oxygen, included 2 O linked together. Now let's draw the extended structure of methane. Moving on to the next topic, we have natural resources and how it impacts society. Plastic. It is made out of compounds that contain atoms such as oxygen, nitrogen, sulfur. In our daily life, we use plastic a lot. We use plastic in water bottle, in plastic bag, and in everything. Let's jump to the next topic, pure substance and thermal energy. There are 3 states of matter: solid, liquid, and gas. Liquid, when atoms slide past each other. For gas, everything moves freely. And for the last one, solid, it's just basically a cube. Sugar is a pure substance. This is when energy is being added to the sugar. As you can see, the sugar from solid is becoming liquid, and times pass, you can see the smoke, and it is gas. In the second unit, chemical interactions, we now have to analyze whether a chemical reaction has occurred. A chemical reaction happens when atoms are rearranged to create something new. These are signs to recognize a chemical reaction: precipitate, color change, formation of gas, and temperature change. When I put the scream inside the water and boil, the heat started to break down carbohydrate and change the color of the scream from gray to orange. The temperature also changed from cold to hot. Mass is conserved. In this experiment, I already make sure that no steam is out of the pot. So as I weigh the pot, 1.31. And this is after I cook the scrim. The mass is still 1.31. Perfectly. Let's move on to the next chapter of this unit, exo and endothermic reactions. An exothermic reaction is when energy is released, whereas an endothermic reaction is when energy is absorbed. Here's an example of an exothermic reaction where energy is being released from the paper. Next unit, motion and forces. Newton's third law. What is Newton's third law? For every action, there's an equal and opposite reaction. When the fruit hit, the first one stopped because the second fruit applied an equal opposite force on the first one. Otherwise, it would have kept going. Next topic, change in motion. So in this example, I will prove how the mass of the objects affect the force they create. I'll drop the marble. It's really light, that's why it doesn't create a lot of force and couldn't push the box really far. And for the bottle, it's heavier, so the force it creates is bigger and the box was pushed further. This time, I'll use 2 forces and show that it is greater than each individual force. Next topic, Newton's first law in real life. So in this example, I will use a ping pong and a football to throw at the bottle. When I use a ping pong to throw at the bottle, it doesn't knock. But when I use a football with the same strength, well, you know. Moving on to the next unit, light and sound, the amplitude of wave. As you can see, I'm drawing a wave and the amplitude is very high, and I draw another one and the amplitude is low. So the higher the amplitude, the higher the energy, and the lower the amplitude, the lower the energy. How waves travel. So this is when the light is reflected by an object and it goes in and comes out at the same angle, 60 degrees. And for this is when the light is being absorbed by an object. It goes in but doesn't come out. And for the last one, the light transmit through the object. In this example, my image is being reflected in the TV. When I move the camera from the light to the curtain is not as bright anymore because it absorbs some of the light. So here's an example of transmission because you can see the paper through the file. And for the last unit, electricity and magnetism, here are the factors that affect electric and magnetic forces. Here are the factors that affect electricity. For the first one, voltage. The second one, the quality of conductor. And the last one, imbalance of charges. You can see that I plugged in the 110 volt. And after that, I plug it in the 220 volt. And the amount of voltage can affect the electricity a lot. In the white wire, that has more bronze, so it conducts less electricity, whereas the black wire is bigger because it carries more bronze, therefore conduct more electricity. When I rub the ruler on the racket, electrons move from the racket to the ruler or the other way around, so the ruler is not neutral in electricity anymore. That's why the ruler has electricity to attract the pieces of paper. And here's the factor that affect magnetic. For the first one, alignment of magnetic domains. And for the second one, the distance. This is an example when you use a compass in the area that has magnet. Then the magnet of the compass will be affected and not balanced. And for this example, as I move the distance of the magnet far away, about 1 centimeter, is when I release it stick, but then when I move really far away and I drop it, because there's the distance between the fridge and the magnet is very far. And for the last topic, we will prove that magnetic field exists. So in this example, I'm showing two magnets exerting force on each other even though they were separated by a ruler. Thank you for watching. Now this is where you clap your hands.